we can see the solutions for the last examples in the integrations by parts is quite complicated, as we need to solve the integral by parts for twice. Indeed, there is actually a shorter solution technique that we call tabular methods. We can use it to solve the integrations problem quickly, provided the integral is the products of exponential, polynomial, or trigonometry functions. There were actually two possibilities here. First, u of x is chosen such that u of x is differentiable multiple times until we get 0. So on the other times, v of x has to be integrated the same amount of time until the derivative of u of x goes to 0. So in the second case, the derivative of u of x or v of x will never go to 0, no matter how many times we differentiate. So in this case, u of x will be differentiated and v of x will be integrated the same amount of time until both of terms have the same term as u of x and v of x, despite their constant coefficients here. To integrate with the tabular method, we will create a table with 4 columns. The first column is the columns for u of x. The second column is the columns for v of x. The third column is the columns for sign, means that either positive or negative. And the last column is the terms. So once we have v of x, we will differentiate it till 0 for the first case, and then we integrate v till u of x 0. And in the second case is we're going to differentiate and integrate till we get the same term as u of x and v of x. Then the sign here, the first one we left it blank. After that is plus, minus, we just alternate the sign. And the terms here means that first term, second term, third term, fourth term. Let's say this is the terms that I have. I'm going to take the first terms in the columns of u times with the second terms in the columns of v, and then take the positive sign. So positive, let's say this is a star, this is a double, no, this is a plus. Okay, this sign. So it's star times with this, with positive. The next, let's say this is A, this is B. So I will take A times with B and take the signs negative A times with B. So the final solution is the sum of all these terms. Let's look at the examples now. In this example, the integrand is a polynomial function times with an exponential function. So in this case, I'm going to choose u as the x because when I differentiate x, there's a possibility if it goes to 0. And I will keep v as the e to the 3x. Now I can create the table u, v, the sign, and the term. So u is x, v is e to the 3x. First one, the sign, I left it blank. And differentiate x, I'm going to get 1. And differentiate 1, I will get 0. Now I'm going to integrate the v for the same amount of time. So integrate e to the 3x dx. I'm gonna to get e to the 3x over 3. And then integrate this e to the 3x over 3 again. We're gonna to get e to the 3x over 9. So let's put the sign now. Plus, minus. And we can get the terms now. Where I'm going to get you this times this and take the sign plus. So I have x e to the 3x over 3. And then I take this times this. I have negative, take this sign, e to the 3x over 9. Okay, so this one have nothing, right? So we stop here. And hence the solutions of this will equal to x e to the 3x over 3 minus e to the 3x over 9 plus c, which is much easier than the previous integrations by Park's formulas, right? Next example, we have an exponential functions and trigonometry function. In this case, none of these functions can be differentiated till we get 0. So in this case, I will just simply choose u equal to e to the negative x and v equal to cos 2x. If you like, you can choose u as cos 2x and v as e to the negative x also. Doesn't matter. Because no matter which one we choose, we have no chance to differentiate it till we get 0. So now let's create the table for u and for v, and then for sine, and finally for terms. So e to the negative x, this is cos 2x. Let me differentiate e to the negative x. I'm going to get negative e to the negative x and integrate cos 2x. We're going to get sine 2x over 2 and differentiate negative e to the negative x again. We're going to get negative e to the negative x, so I get back e to the negative x. And now differentiate sine 2x over 2. I'm going to get negative cos 2x over 2. And initially we have over 2, so now become over 4. Here we can observe that this e to the 2x, e to the negative x is same with the u e to the negative x. And cos 2x here is same with the cos 2x, which is the v. So in this case, we can stop. Okay, just stop when both of the derivative and integrations have the same terms as u and v without considering those coefficients plus or minus and the constant which multiply to the functions. Okay, so now we can continue. The first one left it blank and then plus minus. If we have some more, then just alternate the sign, plus minus plus minus. So take this times with this. I have plus e to the negative x sine 2x over 2. And take this times with this. We will have negative, negative, negative. So it is negative e to the negative x times with cos 2x over 4. So now sum up this thing will give us the solutions 1 over 2 e to the negative x sine 2x and minus 1 over 4 e to the negative x cos 2x plus c. This is the solutions for this problem. So I think that's all the discussions for the chapters of integrations. Thank you very much for your attention. In case you have any problems, you can leave your comments or you may ask in the WhatsApp groups later, or you can ask in our interactive class later. Thank you. Bye.